Welcome back to another Knowledge-Filled Thursday. This week we dive into a fascinating study that assesses the effects of red to far red light ratios and their intricate interplay with plant density, light distribution, yield, and secondary metabolite production. The study utilized two distinct LED light sources, Solray 385 and AP67. These differed in their spectral emissivity of green light and red to far red light ratios, emitting ratios of 12.9 and 3.7 respectively. The researchers tested several hypotheses. 1. A lower red to far red light ratio results in increased biomass. 2. A higher proportion of green light enhances CBD and terpene concentrations. 3. Increased plant density diminishes individual yield per plant. 4. Higher yields and secondary metabolite concentration correlate with areas of peak light intensity. 5. The positive effects of green light on secondary metabolites are more pronounced at higher plant density and in shaded flower positions. The results were intriguing, revealing a significant 16% increase in total dry flower yields under the lower red to far red light treatment. Remarkably, this increase was most pronounced during the last 10 days of flowering. When examining the various light treatments across different planting densities and flower positions, they observed the following. The lower red to far red ratio consistently led to higher total flower yields under both planting densities. Border plants in higher densities yielded significantly less than those in central locations. Interestingly, the study highlighted the major contribution of side branches and side tops to the overall flower yield. This begs the question, should we be prioritizing these areas over apical colas in commercial production? Further findings indicate that while the two light spectra did not significantly increase CBD yields, they notably boosted terpene concentrations by up to 41%. The Solray light source, with its higher red to far red ratio and substantial 45% increase in green light emission, was particularly effective in elevating monoterpene concentrations. Although these results didn't definitively demonstrate the benefits of green light in this study, emerging studies are highlighting its essential role in secondary metabolism and the physiological performance of cannabis. Lastly, both Solray and AP67 achieved photon conversion efficiencies of 0.05 grams per mole and 0.06 grams per mole respectively. It's surprising to note that the highest plant yields were not found under the areas of highest canopy light levels as depicted in these maps. The discrepancy may stem from a lack of CO2 supplementation during the trial, which likely caused light stress and reduced overall performance. This emphasizes the importance of understanding your cultivation environment's limiting factors. As cultivators, comprehending the effects of your light source will empower you to make informed decisions when selecting lighting products that align with your objectives. This study suggests seeking a light source that provides an even distribution of light across the canopy. Additionally, you may enhance your overall yields by increasing the far red spectrum during the final stages of flowering. Thank you for tuning in to today's discussion, and let us at the CRC continue to help you explore ways to optimize your cultivation techniques. Stay informed.